Hello the internet, my name is Wesley and I've been working on building my dream guitar pedal rig. Insert B-roll footage here, and I've got MIDI control over this whole thing, and that means I'm going to need a MIDI controller. In this case I've got the MC6 Pro, but there are lots of competitors in this market. Almost every one of these MIDI controllers has the ability to make like an add-on board of some kind with additional buttons and expression pedals and stuff like that. On this particular unit I've got the only MIDI output I really need, and then I've got all these other ports which can be other MIDI outputs. Again, not going to use it for that. Or it can be up to 3 push buttons per input or 1 expression pedal. So I'm going to use 3 of them for 3 buttons each, and 1 of them for an additional expression pedal, so I'll have 9 extra buttons and a pedal. Basically I need a platform that's going to be something I can like stomp on indiscriminately, that is going to be serviceable, rugged, robust, and preferably maybe kind of unique looking and easy to work with. So it's a freaking speed bump. Now, I know this seems kind of crazy to use like an automotive cable hider as a MIDI control board, but if you look at this, it's actually like really serviceable. You can pop this up. I'm essentially going to be drilling holes in this and using it as the panel to hold all the buttons and all the expression pedals in the unit itself and everything. And it's got like channels in there already. It's stompable, it's rubber, and it's kind of unique looking. So I'm going to show you how I turn this thing into the ground station for my pedal board so that I never have to stomp on all my expensive effects. Okay, it's 2 in the morning and that took longer than I thought it would. I think the hardest part is done, which is removing material from this thing. I used sandpaper on a little block to remove the texture from this part where we're going to be using dual lock to stick down the MIDI controller itself, our volume pedal, and an expression pedal. Just use a step drill bit to put holes in where all the buttons are going to go, and the most difficult and time-consuming part is removing a piece of this strip that divides the 2 channels from each other. I was able to use tin shears to cut out the big chunks, but using a mixture of like a Dremel and a file to get the rest of it was a huge pain, because this material just wants to melt rather than coming off in any type of smooth chips. So it's a bit of a process. Hopefully that is the hardest part done. Okay, it is tomorrow and I've completed the next part of the build. So we have installed all of the foot buttons on this thing. These are SPST, that's single pull, single throw switches, which just means there's 2 contacts on there that are normally open and they close when you step on it. I've also, I don't know if you can see it so good on camera, but I've made the ones that'll be closer to me lower profile, and then used all the thread space available on the back ones to make them as high profile as possible, to hopefully make it easier to step on the one that I want to step on. So when we open up the cable hider, you can see what is going on with the wiring. So we've got 3 clusters of 3 switches that are all grouped together. There's 3 here, 3 here, and 3 here. So basically what's going on here is that we have 4 conductor wire. So one of those conductors is going to be ground for each of these clusters of 3 switches. And so that ground will hit all 3 switches. And then the other 3 conductors, the red, yellow, and white, each go to one of the other contacts on the switch. So essentially all 3 of these switches now close to ground whenever they're stomped on. And then you can also see we've got some adhesive zip tie anchors to just keep everything organized, and it's a little difficult to see on camera, but we've got notches cut out in the center divider using a pair of tin shears that are going to make it so that when these wires cross over, they're not having like strain placed upon them. They have a little place to go when the whole enclosure is closed down. So for the control box, which is going to be mounted in that cutaway notch that's underneath the flap, we're using a simple Hammond 1590B project enclosure. You can find these things all kinds of places. It's like kind of a standard like guitar pedal project box. Unfortunately, space is so limited in there that I'm not going to be able to place the cap on it, but because everything that's happening in this circuit is eventually going to go through a 5-pin MIDI cable that's going through an optical isolator, any noise or EMF that's happening on this whole MIDI controller circuit are not actually going to find their way into the audio path of my guitar pedal board, so I'm not too worried about shielding. So at this point I'm going to drill a couple of holes so that I can use wood screws to just plant this thing down in there. We're going to need a couple of holes in the back for those 3 4 conductor wires to find their way in. And the most crucial and fiddly part is going to be getting these 3 TRS stereo 1/4 inch plugs all mounted in there. So we're going to have to do something a little bit tricky to make it work, but these, as compact as they are, they have these little cutaways that indicate which side is ground. So what we can do is arrange them thusly. You have the cutaways facing each other, and then you have the third one at an angle with the cutaway facing the top. And once these are spread out a little ways, you can see that they'll fit together nicely at a little angle, and then with that cutaway at the top, that will be just low profile enough that it'll all fit in the control box without sticking up and interfering with the closing of the cover on this thing. So I've got some very careful measuring and drilling to do, but once we do that, we're going to be well on our way to completing this project. Okay, so a lot of the drilling we plan on doing with that electronics box is pretty straightforward, but with these 3 jacks, it's going to be very fiddly, and we're not going to get any second chances with drilling aluminum. So what I've done here is take a piece of cardboard, cut it to the size of the available panel space inside, and then just take a few cracks at getting these grouped correctly. Normally what I would do is just like set them all in there and then poke through the middle of them with something skinny like a little screwdriver to get a hole, and then I just drill through them with a power drill the same as I would the actual piece of aluminum. And once I've actually got everything lined up on this little mock-up space, we can test a few important things. So number one, these are really crowded, so I want to make sure that my patch cables will actually fit. So I've got some little Ernie ball patch cables here, and because these are extremely compact, it looks like they actually do fit. So I'm gonna go ahead and rock with this. So now what I can do is use this little cardboard panel as a template that I'm gonna just set down on the aluminum enclosure itself, and then just use a marker to draw out exactly where I need to drill my holes, and then hopefully that'll work. Okay, pretty stoked on how this came out, but you can see with some very careful drilling, using the little cardboard template that we used, we were able to get those in there all nice and snug. So you can see it doesn't really stick out over the top, and everything is looking good. One thing to note is that some important pins that we want to solder to are like right there next to the chassis itself, the chassis, which is going to be grounded. So if they accidentally short, the controller is going to think that that button is just constantly depressed, which we don't want. So we got to be careful not to allow there to be any contact between there. I might even put some like non-conductive tape down to make sure that that doesn't happen. Our other holes are all there, so we should be ready to stick this thing in. Okay, so I've navigated us over to the Morningstar Engineering product page where they show the schematic for how we want this whole thing to work. So this schematic calls for 1N4148 diodes, and these are absolute jelly beans. They're like practically free, they're so cheap. Thankfully I already had a few laying around. We need 2 per jack per cluster of 3 buttons, so I've got 3 clusters of 3, which means I'm going to need 6 of these things. Again, super cheap. And the way this works, it seems like nearly any diode would probably get the job done. So if you have diodes around but not these exact ones, you could probably fudge it a little bit. But essentially what we have going on here is we've got, switch 1 goes to the tip, switch 2 goes to the ring, and then switch 3 actually goes to both the tip and the ring. And then we've got these diodes here to prevent backflow from the other 2 switches, causing interference and making it ambiguous to the controller which of the switches is being pressed. So since switch number 3 is kind of toggling both 1 and 2 simultaneously, it seems like it would be possible to sort of accidentally trick the controller into thinking that you're hitting button 3 if you were hitting 1 and 2 at precisely the same moment. But I'm guessing it would be really difficult to do that by accident. Probably we're not going to encounter the issue of mistaken button presses too much with this design. So overall, I think this is a pretty good system for Morningstar to be using, and I think it would be worthwhile for some of their competitors to maybe consider doing something like this. Like I think RJM makes a really great MIDI controller that's like a direct competitor to the MC6 Pro, but their button expansion system only allows for 2 additional buttons, one on the tip and one on the ring, and I feel like it would probably just be a software change for them to incorporate something like this. So I would maybe encourage other companies to do this as well. But that's not to poop on RGM, because I nearly bought their controller. It seems like it's a really mature product and super well made. Anyway, we're going to take this schematic and we're going to implement it into the control box, and we're on the home stretch here. Yeah, alright, it ain't exactly pretty, but essentially we're just taking two diodes, one from the tip, one from the ring, and we're just going to make them both meet on one of the pins that will be floating once a plug is present in there, and then we're going to take that third wire from that 4-conductor wire that we saw before, and we're going to, put one of them on the floater, one of them on the tip, one of them on the ring, and of course one of them on the sleeve to be ground. Yes, indeedy, this is taking a bit more time than I thought, but we've got our control box with all of the jacks in there, and we just took all the diodes and kind of just baked them right into the little jack socket there, and you can see we've got some additional strain relief in there to make sure that if we're servicing it, it's not pulling directly on the solder joints. So I've just got like these little cable ties here set up to kind of enforce a little bit of a Z-bend. So it does take a little bit of fiddling, like I can't just open and close it freely, but if I put it on the ground and kind of guide it a little bit with my fingers as I close it, it'll sit down flush, and that pretty much sorts it out. We just need to add some dual lock and stick everything on top, so let's do that. Oof, I've just encountered my first big setback with this build. Whatever this stuff is made out of, dual lock does not stick to it at all, and that was a major part of my plan for affixing the MIDI controller and the expression pedals onto this thing. So you can see if I stick this on there, I mean, it takes dual lock a little bit to cure, but like normally even right when you stick it on, it's like decently robust. But this just, it literally, like, you just poke it off like it. So we're gonna have to figure out another solution. Well, I'm out of ideas. Since dual lock clearly ain't gonna work, I thought maybe I could put some wooden wedges on there and attach them to that, but there's nowhere with lumber within walking distance, and if I don't finish this today, I'm gonna freak the hell out. I know for sure that Velcro ain't gonna cut the mustard. I planned on avoiding 3D printing for this project, but I'm gonna have to break down and squirt hot PETG all over my problems like a complete and total degenerate. God forgive me, I've done a lot of sinning. We're gonna have to take a dirty detour through Fusion 360 to get this done, I think. Woof, okay, I know it's gross, but we're gonna pop into Fusion 360 here and make some little wedges that are essentially gonna live on the sloped edges of this little thing over there and make for a flat surface where we can put either dual lock or Velcro on the toe and heel portions of the pedal so that it's not like tipping and wobbling all around. So we got this little wedge shape after taking some measurements. I got some little chamfered holes here where we can use a tool to drill directly into the plastic and hopefully not interfere with any of the electronics. Oh, but there's one more thing. I got a 2017 CR10S, which definitely means the freaking heat bed doesn't work. So I'm just gonna print some giant flanges on here until I get around to fixing it, and then I'm just gonna literally wait for those to print, freaking tape them down to the heat bed, and hope that this thing doesn't curl into a warped nightmare. Make 4 of them, and question mark, profit? Let's find out. Okay, while I'm waiting on the 3D printer to hopefully do its thing, I can test all these buttons to make sure that they're actually working. So here on the floor, I've got the controller itself and then the MC6 Pro down there, and it's plugged into all these buttons using TRS cables. So the first thing I'm going to do is go into controller settings in the editor software, and there will be something analogous probably with whatever controller you're using if it's not a Morningstar product. So I've got expression port 1 set to an expression pedal, and 2, 3, and 4 are all set to aux switch, which is how I've got it plugged in currently. I would probably recommend setting these up before plugging it in just to make sure nothing goes too haywire. Then you're going to do save settings. You'll note that it says requires restart, but in my experience it actually requires a full-on power cycle. I had to yank the cable and get it to plug back in before it would stop pretending like these were expression pedals that were all going awry. So next up, what I'm going to do is go into editor settings and enable this option, load preset data into editor using switch press, because that means it'll flip to whatever preset is bound to that button in the software every time I click one, so that'll let me know which button does what. So now I can just grab any random button. I'll start here on the right, and that's gone over to Q, which means that button is working. This one is R, great, it's working. P, okay, good. So you'll see they're slightly out of order, but I'm just gonna label them, and you know, it just is what it is. Okay, so this one's K, L, J, N, don't ask me why, O, and M. Great. So if I decide to at some point, I can go through my controller settings and go into fixed switch custom, and then essentially like relabel all these to do exactly what I want. Like I can make it, you know, go all in order, so I can remap them, which is why I wasn't super picky about which button landed where on the physical controller, because they can be remapped. So I'll do that on my own time, but looks like electrically everything's working, so great. With the 3D printing finished, you can see we just used some wood screws to attach those wedges to the cable hider and make a flat surface for the expression and volume pedals to sit on. Used a bit of Velcro fastener on the wedges, as well as the spot where the M6 Pro is going to live, and you can see the control box there as well. Great, now that this thing is finally done, I can show you what it actually does. So this is a ground station that provides control to this, which is my actual pedal board where all the audio is processed. This is what my guitar and amp are both plugged into, and this is going to tell that what to do, so I don't have to stomp on my expensive effects or fiddle with them. And in fact, I could have this thing completely like in a box somewhere and play only with this after setting up presets. So essentially all these buttons are plugged into this unit here, and I've programmed each of them to do something different, and they're very, very customizable. So if I just tap that button there, it's going to mute my guitar signal and activate the tuner, which you can see here. And you know, I'm a little smidgen out of tune, but we're not going to worry about that too much for now. So next up, that button is a little bread and butter sound light drive. And then next up, I've got a heavy drive. You can hear there's a lot of delay there. So for this patch, I've got this expression pedal set to control the mix amount on the delay. So but it doesn't have to do just that. If I load up another patch, this has got a little tremolo on it. As I roll the toe forward, the tremolo depth increases. So the expression pedal can be assigned a unique function for every patch that you build. So next up here, we've just got a nice little chorus. And I've got a couple of blank ones, and then over here I've got like a giant echoey reverb thing. And that weird bouncy delay with the pitch shifting is because we've sent my delay a different program than what it uses for, say, the heavy overdrive. Same pedal, but it sounds completely differently because we've given it a program change from the MC6 Pro over here. And then this last button over here is just a tap tempo. So all the divisions are set differently on these, but you can see the lights blinking really fast. If I tap it like slow, you'll see them slow down. So that affects all my pedals. But you know, you can configure it to include or exclude certain ones on a per patch basis. And then last but not least, I've got a nice little volume pedal over here. So there's no MIDI control on that. That's just hardwired into a Moog MF Boost pedal. So that's more or less what the whole thing does. I thought this project was a lot of fun, and I think I'll get a lot of use out of it. It takes a little bit of effort to add new programs and stuff, but by setting up copy and pastable templates, I think I've lowered the barrier enough that I'll actually use this, and I'm excited. And you know, I definitely consider doing a project like this if you've got one of these MIDI controllers, because it's not that hard, and it's a lot of fun, and you can make something that looks unique and feels cool. So Next up, I'm going to be doing a video about the little box that I built that lives inside the pedal board and distributes the MIDI signal from the one port that's on this controller to the 8 devices that are packed into this pedal board. So if you want to see how I did that, feel free to subscribe, and hopefully that'll come out in the next week or two. The project is done and the footage is there, but you know, it's a pain to upload everything. So I've been Wesley. Have an awesome day. Take care.